Okay, Bismillahirrahmanirrahim. So today we are just going to be start the transformation. Okay, the transformation is just you have to say that it is just going to be look like you are doing some magic with you have an object, you are going to be do some magic with it, and it is going to move from one place to another place. If it's a smaller thing, it will become a bigger one. All right. For example, if the object is going to look like this, it is going to become rotate, right? So like these things we have to be do it. So we have to do it with the magic of maths today. Okay, in mathematics, we are just going to be do the four types of transformations. The first type of transformation that is the translation. When you are doing the translation, so the object is moved from one place to another place. All right. The second thing that we have to do that is the reflection. The third thing, the reflection is you are going to be just see yourself inside the mirror. All right. So basically, you are getting see the reflection inside the mirror. The third thing that is the rotation. Rotation means you are going to be rotate any object. The fourth one is the enlargement. Enlargement means the object is bigger. You have to do something, it will become a smaller. Or the object is smaller, you have to do something, it will become a bigger one. So these four types of transformation, inshallah, we are going to be doing. All right. Now, the one basic information about here, if for example you are going to be do the translation, if you are going to be do the translation, so you need to be need the translation vector is needed. All right, the vector is going to look like this, and it is the same vector. If it is positive, you have to move toward the right side. It is negative, move toward the left side. If y is positive, move upward. If y is negative, move downward. The second thing that is the reflection. For reflection, we need a line of reflection. If you want to do the rotation, for rotation, we have three things. The first thing, the angle. We are talking about 90 degree, 180 degree, 270 degree. We will make it 270 with the help of 90 degree. The angle, the second thing that we have to be talk about that is center of rotation. In short, we have to write COR. And the third thing that we are going to talk about in the rotation that is direction. The direction means you are rotating in the clockwise direction or in the anti-clockwise direction. Next thing is enlargement. The enlargement we have to need the first thing that we need here that is the scale factor. In short, we have to write SF. The second thing that we need in the enlargement that is the center of enlargement. That is CO. Yes, everyone. This is the whole transformation that we will do, inshallah. We will do the translation, reflection, rotation, enlargement. I have to write all the basic things here because the most common mistakes, for example, if your examiner says that you have to do the translation, so in translation, some of the students are going to be trying to find the direction. Obviously, we don't have any direction. We don't need any direction here. In the same way, if the examiner says that you have to redo the rotation, or the rotation is given, so you have to find these three things. You don't need to find a translation vector. There is no light, no reflection there. All right. So that's why I have to write all the basic. If you have translation, so you have to find translation vector. If it is reflection, you need a line of reflection. If it is rotation, you need an angle, center of rotation, and direction. If it is enlargement, you need scale factor and center of enlargement. Now, the types of questions that you have to be see in the transformation, that is the two types of questions. The first type, in this question, the examiner give you the object, means the object is given. The examiner gives you the transformation as well. Transformation. For example, the object is given, he says that the translation, do the translation. So obviously examiner gives you the translational vector. If he says that do the reflection, so examiner gives you the line of reflection. If examiner says that you have to do the rotation, so examiner gives you the angle, center of rotation, as well as the direction. In the same way, if examiner says that you have to do the enlargement, so for enlargement you must have the scale factor and center of enlargement. So the first type of question, that is transform the object, the transformation, you have to make the image. The second type, the examiner says does describe. Describe means the examiner gives you the object as well as examiner gives you the image. You have to be tell them he do the translation, he do the transformation, he do that rotation or enlargement or reflection. Means the object is given, image is given as well. You have to tell the transformation. For example, if that is the translation, you need to be tell them what is the vector. If it is reflection, you have to tell them the line of reflection. If that is the rotation, you need to be tell the three things: the angle, center of rotation, and direction. And if that is the enlargement, so you have to find the scale factor and center of enlargement. Yes, I got any question up to here?
No, sir.
No, sir.
No, sir.
All right, now we are going to be started from a very easiest one, that is the translation. Just a minute. So we are doing the I just told you the translation. The translation is you have to move the object from one place to another place. In short, you have to say that move a object from one place to another without any rotation, without doing anything. Okay, exactly. You have to move it from one place to another place. You don't have to be do anything with the object. All right. Yes. What is the things that we need to be required for the translation? I just told you.
Translational vector.
Yes. The required thing is you need a translational vector. The vector is exactly the same. You have x and y. If it is positive, means you have to move towards the right side. If it is negative, you have to move towards the left side. If it is positive, you have to move upward. If it is negative, you have to move downward. Right? For example, I'm going to give you the example and say that translate by a vector minus 2 plus 5. All right. And here is the object. Let's say this is the object. This is our object. So look at here, we have to do minus 5 plus minus 2 plus 5. Minus 2 means we have to move 2 places left side and 5 places upward. I have to make a square grid, so basically I'm going to be taking each block as one place, okay? So minus 2, so 1, 2. 5 places upward, 1, 2, 3, 4, 5. So this point is going to be over here. Now talking about second point, 1, 2, 1, 2, 3, 4, 5. This point is going to go here. In the same way, this point, 1, 2, 1, 2, 3, 4, 5. Yes, everyone, any question up to here? How I have
Yes.
to draw this point?
No. No, sir.
Now just meet them. So that is your image. After the translation of vector minus 2 and 5. This is your first type of question. The examiner give you the object, the transformation. You have to do the you have to do the you have to make the image. Any question up to here? Anyone?
No, sir.
All right. Let's do the second type of question. In the second type of question, the examiner gives you the object as well as he is going to give you the image. You have to make the object. So the question is, describe the following transformation. All right. Let's say I'm going to be draw one object here. The object can be anything, okay? I'm taking a right angle, but it can be anything. It can be a square, it can be a circle, it can be any other shape, right? All right. Let's say this is the take it here, let's say. I'm going to say that this is your object and this is your image. You have to find the translation. So how you will find it? You will move from object to the image. So how you will get that it is a translation? If the object and the image are exactly same, means there is no difference. The size and the rotation or the angle, everything is going to be exactly the same. So we have to say that it is translation. So we have to move from these are the two corresponding points. These two are the corresponding points. And these two are the corresponding points. So you have to find the distance any two corresponding points. You have to move from object to image. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to move 9 places toward the right side. It is positive 9, negative 9.
Positive.
Positive 9. Yes. 1, 2, 3, 4. 4 places upward. So it's 9, 4. You have to say that it is translation with vector 9 and 9 and 1, 2, 3,
4.
4.
4.
9 and 4. That's it. Yes, everyone. Any question over here? This is
No,
your
sir.
this is your translation. It's very simple. Look at here. Your object is here. You have to be do something. You have to make the magic, and they are shook, and it will become here. All right. So this in mathematics name we have to say that it is translation. Now, second thing that we have to be do that is reflection. Okay, the reflection is you are the you have to use you can understand it. You are going to be see you inside the mirror, or you are going to see any object inside the mirror. The most important point for the reflection is the object and image are opposite side of, yes, in reflection which thing we have to use, the line of reflection are opposite side of mirror. You can say that line of reflection. The second most important thing he is going to be here, that is the object distance and image distance from line of reflection or mirror line is equal or same, right? Yes. So what are the main important things that we need to be need here? What is the requirement for the reflection?
Angle 90 or 180 or 270.
Reflection.
Line of reflection.
Yes. We need a, which thing we have to need here? The line of reflection. Okay. Okay. At your level, the line of reflection, obviously, there's sometime if the examiner gives you the object and the line of reflection, you have to make the image. All right. And if examiner is going to give you the image and give you the object, you have to be draw the line. You have to do a very specific types of reflection lines. The one line that is y is equal to x. Yes, which type of line it is? This is the line from left to right, it is moving upward. The second type of line that you can see here, that is y is equal to minus x. This is the line from left to right, it is moving downward. You have to see the line y is equal to plus minus c, means any constant. Y is equal to plus minus c. This is the line that is a horizontal line, y is equal to 2, y is equal to 3, y is equal to 5, like this. You have x is equal to plus minus any constant, means x is equal to 2, x is equal to 4. This is your basically a vertical line. or here going to be say that you have to be find it on x-axis or on y-axis. Basically, it is exactly the same type. Here you have y is equal to 0, and here you have x is equal to 0. Y is equal to 0. Obviously, that is your horizontal line on the x-axis, and x is equal to 0. That is your vertical line on y-axis. Yes, everyone. Any question? These are the different types of lines that you can be seen in your exam. Let's we have to talk about the image. The question is, do the reflection y is equal to x. All right, I'm just making a roughly sketch. Okay, let's say this is a line y is equal to y is it is y is equal to x because one rise, one run, one rise, one run. The gradient is 1. Okay, so I'm going to be taking any object here. Same as I'm going to be taking a triangle here. All right, I need to do the reflection. Okay, I have to write the 2 points above. I have to say that the distance of the object is and the image from the line of reflection is always equal. You want to make the image. Look at here, this is the first type of equation. The reflection is given. Examiner gives you the transformation. Examiner gives you the image. You have to make the object. So what you have to do, you have to take the perpendicular distance from line of reflection. So let's have to take the perpendicular distance. The perpendicular distance are always making a 90 degree. So look at here, 1 diagonal, 2 diagonal, and half. So half, 1 diagonal, 2 diagonal. I'm using this point because here it is say that the object distance and image distance are always equal. So I have to take the distance of the object from line of reflection. So I have to take it from the image point. In the same way, we have half diagonal. So half diagonal will be here. We have 1 diagonal, 2 diagonal, 3, sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It will become here. You will get the 3 points. Just meet them. You will get the image. Your A point will become here, A dash. Your B point will become here, that is B dash. The C point will become here, that is C dash. So if you are going to be make the image, you have to take a perpendicular distance. Be careful, okay? So this is your perpendicular distance. Obviously, it is y is equal to x. So simply, it is a simple diagonals. One rise, one run, like this. Yes, everyone. It is clear that how I have to make the image with the object, with the help of the object and given translation.
Yes, sir.
Yes, yes, sir.
Same way that it can be like this. For example, you have a line y x is equal to something, let's say, and you have any object here. Let's say I'm going to take this one. So take the distance, a perpendicular distance, 1, 2, 3, 4 points. So 1, 2, 3, 4 points. This point will become here. 1, 2, 3, 4. 1, 2, 3, 4. This point is going to be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is going to be here. The same way 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This point is going to be here. So here you will get the image. This is your object. It is your image. After reflection, any line x is equal to, let's say, 2, or any line. Yes, everyone, any question?
No.
No, sir.
No, sir.
No, sir.
All right. Okay, now we have to do the reverse. In the reverse, what it is? What is the second case? You have to describe, right? Examiner gives you the image. It is going to be give you the object. You have to tell the transformation. Now look at here. Let's say this is the example. It is given that this is the object, this is the image. All right. So how you will find it? For your easiness, let's we have to make a grid here. It is x-axis, it is y-axis, it is 1, 2, 3, 4, 5, 6, 7, and so on. Okay. In the same way, we have points here: -1, -2, -3, +1, 2, 3, 4, 5, 6. The examiner gives you the object. The examiner gives the image. You have to be find the transformation. Okay. Look at here. There is no line is given here. Examiner says that you have to describe the transformation. How you will check that it is a reflection? Anyone? Look at here. Here in the translation, the object, the image are exactly the same. So clearly you can see that the object and image are not exactly same. This means that, and if you are going to talk about the size of the object and the size of the image is exactly the same as well. This means that it is not the enlargement as well. So you have two things. It can be reflection and it can be rotation. How many options you have? If examiner gives you the two objects, they are not exactly the same, and obviously the size is not same as well. So you have two options. It can be reflection and it can be rotation. So you have to meet the corresponding points. You have to do the, let's say I'm going to meet the corresponding points. This is the corresponding points. These are the corresponding points. Yes, what is the common thing that you can see in all the lines? Yes, everyone? There is any similarity in these lines?
But they're horizontal.
They are horizontal or, okay, they are parallel. They are, we have to do it here. Let's say if you are going to meet the corresponding points here, it's B, it is A, it is C. So look at here. What you can see here, when you have to meet the corresponding points, so the lines are going to be parallel. So always remember, if examiner gives you the image, the examiner gives you the object, he says that you have to tell the transformation. You have to meet the corresponding points. If the corresponding points, if the lines are going to be parallel, this means that it is reflection. So we have to get the one thing, it is reflection. Yes, what is the second thing that we need to be find? We need to be find the line of reflection. How you will find the line of reflection? You have to meet two corresponding points, so you have to move the steps one by one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8. 6, 7, 8, 9, 9. So where both of them are going to be meted, that's you will get the point. Basically, you have to find the midpoint of the line. In the same way, if I'm going to meet these two corresponding points, so find the midpoint 1, 2, 3, 1, 2, 3, 4, and 4. So look at here. Basically, you have to take the first step from here and one step from here. Where you will meet it, that's your point. You will get the 2 points. Just meet them. That will be your line of reflection. So you will get the line of reflection x is equal to 2. Yes, everyone, the procedure is clear.
Yes, sir.
If you want to find, if the examiner gives you the object and image, you have to describe the transformation. First of all, you have to check that what it is. It is translation, it is reflection, it is rotation, enlargement. In translation, the object and image is exactly same. They are not exactly same. This means that it is not translation. In rotation, the object is going to be rotated, and in enlargement, the object size is going to be bigger or smaller. So clearly, the size is not changing. It is exactly the same. It means that it is rotation and reflection. So you have to meet the corresponding points. If the lines are parallel, means it is reflection. If the lines are not parallel, means it is rotation. So here we have some important points. You have to check. It is reflection or rotation. What you will do, you have to meet the corresponding points with a line. So the first thing, if are lines are parallel, yes, what does it mean?
It's a reflection.
It is reflection. Then if lines are not parallel, means it is rotation. Because in reflection and rotation we have to be confused. So this is how you have to check that the given thing is going to be reflection or rotation. Yes, everyone. Any question up to here?
No,
No,
sir.
sir.
Yes, sir.
We'll go for the topical questions, but still you just have to be understand that how we can do the reflection, and everything point is going to be important. Okay. If you have a strong grip on these points, you can easily do the transformation of any types. All right. The next we have that is the rotation. I just told you what is the requirement. What are the required things? The
Angle
first,
90, 180, or 270.
yes, the first thing we you have to have the angle of rotation. The angle will be the rotation that we will do, that is 190 degree, 180 degree, 270 degree. All right. And the important point, we make 270 degree with the help of 90 degree, like this. For example, examiner says that you have to do a 90 degree clockwise or 270-degree anti-clockwise, so both are the same thing. Let's see. He says that 90 degree clockwise. So this will be 90 degree clockwise. Is it clear?
Yes, sir.
In the same way, you have 270 degree clockwise, 90 degree anti-clockwise, 180 degree anti-clockwise, 270 anti-clockwise. Look at here, they are exactly. I have to do 90 degree clockwise. I have to do 270 degree anti-clockwise. So look at here, after rotation, they are going to be exactly the same. So this means that you have to say 90 degree clockwise or 270 degree anti-clockwise, both are the same thing. All right. So we have rotation. So the required is angle of rotation. So we have to be 90 degree, 180 degree, and 270 degrees. So second thing, we have a direction. Direction means you are doing a clockwise. Means we have to write CW or anti-clockwise or counterclockwise. ACW. All right, sometimes we have to write counter clockwise. We have to write CCW. The third and the most important thing that we have to find, that is center of rotation. It's basically a point like this. Yes, everyone. Any question up to here?
No, sir.
No, sir.
No, sir.
All right. I'm just going to be write the steps today, and we will do the steps inshallah in the next class. You can say that the method or procedure or the steps. Okay. The first step that we have to do, you have to take the distance from center of rotation to object point. What is the first step? You have to find the distance from center of rotation to the object point. Let's say the distance is going to be like this. For example, this is your object point and this is center of rotation. So the distance is 1, 2, 3, 4, 5, 6. 1, 2, 3. The distance is 6, 3. It is clear? The
Yes,
second thing, you have to be, the one thing that we have to do the rotation, we have to do it by the tracing paper, but we are doing with the formula. We have to apply the formula on the distance, so you will get the new points. All right, this will become a new point. Look at here, I have to make small xy, I have to make it plus xy, just make it distinguish. You have a new distance, it will become new one. The third thing, this is basically a distance from center of rotation to image point. All right. Now, in all of these, what is the first step? You have to take the distance from center of rotation to the object. The first thing, you will get the distance, apply some formula on it. The third thing, that is the distance, that is basically a distance from center of rotation to the image point. All right. Now, the question was, what is the formula? We have to talk about, we have to apply the formula. So what is the formula here? If examiner says that you have to do the 90-degree clockwise rotation or 270-degree anti-clockwise rotation. Sorry. Okay, so we have to do the 90-degree clockwise rotation or 270-degree anti-clockwise rotation. So for example, this is the distance that you have find. So what you have to do, you have to interchange them and change the sign of the y coordinate. For example, you have to find the distance 4, 2. So it will become 2, 4 and change the coordinate sign of the y coordinate. All right. This is how you have to apply the formula. The second thing, you have to do the 90-degree anti-clockwise rotation or 270-degree clockwise rotation. Both are exactly the same thing. You have a distance xy. It will become, change this xy will become yx, and now change the sign of the x coordinate. For example, you have to find the distance 2, -5. So interchange them, -5, 2. Change the coordinate or sign of the x coordinate, that will be +5. The third thing, the examiner says that you have to do the 180-degree. You have to do 180-degree clockwise or anti-clockwise. Both are the same thing. For example, you have the object. So look at here. If I'm going to rotate 180-degree like this, the anti-clockwise direction, or you have to rotate 180-degree clockwise. In both things, you are going to be getting the same thing. All right. It doesn't matter you are moving in the clockwise direction or anti-clockwise direction. So what you will do, this is the distance of center of rotation to the object point. You have to change it the sign only. Yes, everyone. Any question up here?
No.
No, sir.
Right, these are steps.
No, sir.
So just give me 1 minute. I'll do one question because without question you will not understand it. Just a minute. Transformation. Yes, look at here. I'm going to take it on my screen. We are talking about this point only. Okay, let's do the first part as well. I'm going to focus on this point. He says that you have to do the rotation of about 0, 0. So center of rotation is 0, 0. In this case, it is 0, 0. It can be any point. It can be 2, 3 or 5, 3. He says that you have to do the 90-degree clockwise rotation. So yes, what is the first step? The first step is we have to take the distance of center of rotation to the object point. So let's see how to take the distance. 1, 2, 3, and 1. So the distance is 3, 1. The second one is 1, 2, 3, 4, 5, 6, and 1. So it will be 6, 1. The next will be 1, 2, 3, 4, 5, 6, 1, 2, 3. So the next distance is 6, 3. Here the center of rotation is the origin. That's why you are going, the point is exactly the same. Okay, but you have to take the distance like this way. Yes, everyone. Any question up to here?
No,
No,
sir.
sir.
No, sir.
Now, what is the formula? We have to do the 90-degree clockwise. For 90-degree clockwise, I told you, you have to be interchange them and change the sign of the y coordinate. The formula is the xy will become, change it and change the sign of y coordinate. So 3, 1 will become 1, minus 3. 6, 1 will become
Minus 1 and then 6.
Minus 6.
minus 6. 6, 3 will become
3 minus 6.
minus. Let's see, take the distance. So 1 minus 3. X1 minus 3. 1, 2, 3. Sorry, from center of rotation. This is the center of rotation. 1, 1, 2, 3. This is the point. Now 1, 1, 2, 3, 4, 5, 6. This will be the point. Next, 1, 2, 3, 1, 2, 3, 4, 5, 6. The point is going to be here.
Okay, sir.
So you will get the rotation. You can see it. Look at here. You have to be rotated. If I'm going to be more clarify you. Look at here. We have to do our 90-degree clockwise rotation. It's just it. Yes, everyone. These steps are clear. What we have to do? We have to take the distance from center of rotation to the object point. The first thing, we have to apply the formula. It depends upon you are doing it in 90-degree clockwise or anti-clockwise or 180-degree. And then you have, that is the distance from center of rotation to the image point. Plot the image point and you will get the image. Yes, everyone. Any question?
No, sir.
No, sir.
No,
Given
sir.
here, position of a triangle T by a vector minus 3 and minus 7 and 3. Minus 7 and 3. Minus 7 means 1, 2, 3, 4, 5, 6, 7. Minus 7. 1, 2, 3. This point is going to be here. In the same way, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. In the same way, this point is will become here. So you will get a triangle. Yes, everyone. Any question up to here?
No, sir.
No, sir.
Next class, we are going to be do the reverse question.